Geometric series. So we just looked at an arithmetic series where we were adding a common difference every time to our previous number in the series. So a geometric series is where we're multiplying by a common ratio each time. And an example of a geometric series is going to be 2 plus 4 plus 8 plus 16 plus 32 plus ... So here we're multiplying by 2 each time to build our series. And this is what we call the common ratio. So our common ratio in this case is 2. And we get the common ratio by taking the second term and dividing it by the first term, or the third term and dividing it by the second term, or the fourth term and dividing it by the third term, and so forth. So our common ratio can be negative if this alternates with positives and negatives as well. And just like a arithmetic series, we have a equaling the first term and n equaling the number of terms in the series. And to get any term in the series, we have a formula that Tn equals a times r to the power of n minus 1. So this, again, is the nth term in our series, and a is the first term and r is the common ratio, and n is the number of terms. Let's have a look at how we can use that term formula. So let's look at the series 2 plus 6 plus 18 plus 54 plus 162 and so forth. And we're after the 8th term. Well, here we recognize that we do have a geometric series because we're multiplying by 3 each time. And if you didn't see that, you could get the common ratio by taking the second term and dividing it by the first term, which is 6 over 2, which is 3. We know our a is equal to 2, that's our first term. And our n in this case is going to be 8 because we're after the 8th term. So we can get our 8th term by we can use our formula, a times r to the n minus 1. So a is equal to 2, that's our first term, times our common ratio, which is 3, to the power of 8 minus 1. So we get 2 times 3 to the power of 7, which is going to give us 4,374. Let's look at another series. We've got 16 plus 4 plus 1 plus a quarter plus a 16th plus a 64th and so on. This time our first term is 16. Our common ratio, well, we can get the second term and divide it by the first term to give us 4 on 16, which is a quarter, and we're after the 12th term. So we can use our formula that the nth term will be a times r to the power of n minus 1. So the 12th term will be our first term 16 times our common ratio, which is a quarter, to the power of 12 minus 1. So we get 16 times a quarter to the power of 11, and that's going to equal 1 over 262,144. So just like an arithmetic series, we can also find the sum of a geometric series, the sum of the first n terms. So the sum of the first n terms is going to equal our first term times our common ratio to the power of n minus 1, all divided by our common ratio minus 1. And we usually use this formula if r is greater than 1. Or if r is less than 1, we can use this formula where the sum of the first n terms is going to be a outside of 1 minus r to the n over 1 minus r. So again, where a is our first term, r is our common ratio, and n is the number of terms we need to sum. Let's have a look at a series. So we've got 1 minus 2 plus 4 minus 8 plus 16 minus ... So here, our first term is equal to 1. Our common ratio, well, we'll take the second term, which is minus 2, divided by our first term. So we get minus 2. So because our pattern is alternating here of plus, minus, we know the common ratio has to be negative. And we're after the sum of the first 9 terms. So in this case, our r is less than 1, so let's use the second formula. So then the sum of the first 9 terms is going to equal a outside of 1 minus r to the n over 1 minus r. Our a is equal to 1, outside of 1 minus our r is equal to minus 2 to the power of 9, divided by 1 minus our r, which is minus 2. And if we evaluate all of this, we'll get 171.